Okay, here we are for Lesson 12, Decimal Expansions of Fractions, Part 2. So for example 1, our goal is to write the decimal expansion of a fraction, in this case 35/11ths. To do so, we begin by locating 35/11ths on a number line. What is its approximate location, and explain. Well, the number 35/11ths would lie between 3 and 4 on the number line, because 35/11ths is equal to 33/11ths plus 2/11ths, which is equal to 3 plus 2/11ths. So the goal is to use rational approximation to determine the decimal expansion of a number, instead of having to check a series of intervals as we did with decimal expansions of irrational numbers. To determine the decimal expansion of 35/11ths, focus only on the fraction 2/11ths, then methodically determine between which intervals of tenths 2/11ths would lie. Given that we are looking for an interval of tenths, can you think of a way to do this? Well, we know that 35/11ths has a decimal expansion beginning with 3 in the ones place, because 3 plus 2/11ths. Now we want to determine the tenths digit, the hundredths digit, and then the thousandths digit. So here we are with our typical model of place value that you might have seen in second and third grade. And we have a 3 in the ones place with a decimal point after it. So to figure out the tenths digit, we will use the inequality based on tenths. We are looking for the consecutive integers m and m plus 1 that 2/11ths would lie between when m and m plus 1 are intervals of tenths. In other words, in which interval could we place the fraction 2/11ths? So it's either going to be m over 10 is going to be less than 2/11ths, and then m plus 1 over 10 is going to be greater than 2/11ths. So here we have our number line magnified again and partitioned into 10 equal parts, from 3.0 to 4.0. So one of these tenths, either 3 over 10, and then the next one would be 4 over 10, or maybe between 5 over 10 and 6 over 10. Which one of these is 2/11ths going to be in between? Because we know it's not going to be equal, because again 11 doesn't share any common factors of 10 like 10 does. So you could set it up like this also. The first tenth, 1/10, would be 1 over 10. Remember, 1 is the m, and that is a integer. Or we can have 2/10, 3/10, 4/10, all the way to 11/10, which is 114 over 10. So any of these numbers or integers in the numerator is going to equal m, and then the next consecutive integer would obviously be m plus 1. So multiplying through by 10 will eliminate the fractions at the beginning and at the end of the inequality. Therefore, we get m is less than 10 times 2/11ths, which is less than m plus 1. So now we have 10 times 2/11ths, which is 20/11ths, and that can be written as 11/11ths plus 9/11ths, or 1 and 9/11ths. So therefore, m has to be 1. Why does the statement that 10 times 2/11ths equals 1 plus 9/11ths imply that m is 1? Well, it implies that m is 1 because m and m plus 1 are consecutive integers. So the m is the first integer, and the next integer would obviously be 2. Well, since 10 times 2/11ths is equal to 1 plus 9/11ths, the number 1 and 9/11ths would be between the two consecutive integers 1 and 2. Therefore, m has to be 1. So now that we know the decimal expansion of 35/11ths has 1 in the tenths place, so here we have our 3 in the ones and 1 in the tenths, let's move on to the next one. So 35/11ths is equal to 3 plus 2/11ths, and the decimal expansion of the number is 3.1, or 3 1/10. So now we need to find the difference between these two representations. In other words, we need to find out what is left over after we remove the 1/10 from the fraction 2/11. So we have 2/11 minus 1/10 is equal to 20 110ths minus 11 110ths, and that would give us 9 110ths. So the difference between 2/11 and 1/10 is 9 110ths. So the next step is to find out which interval of hundredths will contain the fraction 9 110ths. So we partition our number line, magnifying it again between 3.1 and 3.2, and we get our 10 partitions. So the process is going to be the same as looking for the interval of tenths. That is, we are looking for consecutive integers m and m plus 1, so that m over 100th is less than 9 110ths, which is less than m plus 1 over 100. So by what number should we multiply each term of the inequality by to make our work here easier? Well, we would multiply by 100, because that will eliminate the fractions at the beginning and the end of the inequality. So multiplying by 100, we get m is less than 900 110ths, which is less than m plus 1. So between which two integers, m and m plus 1, will we find the fraction 900 110ths? Well, the fraction 900 110ths is between 8 and 9. The reason for that is that 900 over 110 is equal to 880 110ths plus 20 110ths. And therefore, that is 8 plus 2/11ths. So now we know that the decimal expansion of 11/35 has an 8 in the hundredths place. And so now we have 3.18. So back to our original goal, 35/11ths is equal to 3 plus 2/11ths. By substitution, we now get 35/11ths is equal to 3 plus 1/10 plus 900 110ths. So now we can actually write this as 35/11ths is equal to 3.1 plus 900 110ths. So we know that 35/11ths is 3 plus 2/11ths, and our work so far has shown the decimal expansion to be 3 1800ths, which is 3 plus 1/10 plus 8 100ths. So as before, we need to find the difference between 2/11ths and the expression 1/10 plus 8 hundredths. So 2/11ths minus the quantity of 1/10 plus, and actually that should be plus 8 100ths, is equal to 2/11ths minus 18 hundredths. So now we have 200 11 hundredths minus 198 over 1100. When we subtract that, we get 2 11 hundredths. So then by substitution, we get 35/11ths is equal to 3 plus 1/10 plus 900 110ths. We can again write this as 35/11ths is equal to 3 plus 1/10 plus 8 100ths plus 2 11 hundredths. And we can write that again as an expression 3.18 plus 2 11 hundredths. So now look at the interval of thousandths. Where do you expect 2 11 hundredths to lie on the number line? Write and explain a plan for determining the interval of thousandths between which the number belongs. It is the same process as we've used before, so pause the video and try it on your own before continuing. All right, let's see what you came up with. So first we know that 2 1100ths is equal to 2 11ths times 1 100th. The reappearance of the fraction 2 11ths is meaningful in that we can expect a decimal digit to repeat, but in a different place value since we are now looking for the thousandth digit. We are looking for consecutive integers m and m plus 1 so that m over 1,000 is less than 2 1100ths, which is less than m plus 1 over 1,000. So what do you think we should multiply each term by? If you said 1,000, you are correct. That will eliminate the fractions at the beginning, at the end, and at the end of the inequality. So multiplying through by 1,000, we get m is less than 20 11ths is less than m plus 1. However, we already know that 20 11ths is equal to 11 11ths plus 9 11ths, and therefore we have 1 plus 9 11ths. This should look familiar. So the next digit in the decimal expansion of 35 11ths will be 1 again. So as before, we have the reappearance of the fraction 9 11ths, so we can expect the next decimal digit to be 8, followed by the reappearance of 2 11ths, and so on. Therefore, the decimal expansion of 35 11ths is 3.1818, repeating. Go ahead and perform long division algorithm on the fraction 35 11ths and be prepared to share your observations. So how is this method of rational approximation similar to the long division algorithm? You should notice that the algorithm became repetitive with the appearance of the numbers 2 and 9 alternating with each step. The method of rational approximation is similar to the long division algorithm. All right, to exercises 1 through 3. Go ahead and complete each exercise one at a time. Check your process of rational approximation after each one. Go ahead and start with exercise 1. All right, you should be done with exercise 1. Go ahead and check your work. Again, we are not just using long division. You have to use the process discussed in this lesson and using a rational approximation to come up with the answer. All right, go ahead and do exercise 2. You should be done with exercise 2. Go ahead and check your work against the work here. If you have any questions, please make sure you bring it to class. All right, you should be on exercise 3. And you now have finished exercise 3, so here's the answers for that one. All right, let's wrap this up. Using rational approximation to write the decimal expansion of a fraction is similar to using the long division algorithm. Use the method of rational approximation to write the decimal expansion of a fraction instead of guessing and checking intervals of tenths, hundredths, thousandths, etc. Using computation, we can determine the interval that the decimal lies in. All right, we'll see you in class.